Hello class, so here we go. Geometric series. We kind of talked about them already. We're trying to find the sum of a geometric, so when you're multiplying. So like number one. So our first way is, aren't we multiplying by 2 each time? So can't we find the next two terms, which is going to be 16 and 32? So that's pretty easy. And can't we just add those up on our calculator? So for now, that's how we're going to do these ones, because that's always a backup way. But it's not the best way, because when we start getting about 20 terms, you're going to have a lot to type in on your calculator, and that's just not a useful way to do it. So try doing 2 and 3 right now, and then we're going to learn a lot easier way using a formula that will make it so much easier for us. So go ahead and do 2 and 3. Okay, if you need more time, pause it, and we'll start back over. But let's go on. We're going to learn just our vocab, like normal, which is pretty much the same thing, and then the formula. So our vocab, still R, isn't it what you multiply and divide by? A sub 1 is our first term. A sub n is our last term. S sub n is sum of all the terms. And n is how many terms we have. So let's look. Here's our geometric series formula. I don't keep doing that. I always write sequence. Series. Series means sum. So S sub n equals A sub 1 times 1 minus r to the n over 1 minus r. So now that we have that down, A sub 1, 1 minus r to the n over 1 minus r. If we go back to here, look at number 1. Isn't our A sub 1 going to be 1? Isn't our r 2? And what's our n? How many terms do we want? Well, don't we want 6 terms? So when we plug 6 for our n right up here, when we plug 2 in for these two r's, and when we plug 1 for this a sub 1, and then you just plug this into your calculator and we get our sum of that term that easily. This equation will make that sum a lot easier when we get bigger numbers, because with those tiny ones, you could do it on your calculator, but that takes way too long, so it's not beneficial. So this formula is going to be the easiest way to get through that quicker. Now we have one other. It's called an infinite geometric series. So an infinite geometric series is when it goes on forever. That's what infinite means. So we're trying to find the sum of something when it goes on forever. The only problem is when it goes for infinite time, our r must be less than 1. Because if our r is greater than 1, won't our numbers just keep getting bigger and bigger? And if we go on forever, won't it just get to infinity? So when you add them up, it's just going to be infinity. You can't get an answer. But if we have a r that's less than 1, we keep getting smaller and smaller and smaller. So when we add them all up, we get to a certain number. So our formula for this one is a sub 1 over 1 minus r. It's a really easy formula. So if we have like this example right here, this is 0.7 repeating. That's what that line means, repeating. So isn't this the same thing as writing 0.7777777 forever? So can't we split that up into like 0.7 plus 0.07 plus 0.007? See how if we just add another 0 before the 7, when we add them all up, when we get the same thing? So couldn't our a sub 1 be the first term, which was 0.7? And how do you go from 0.7 to 0.07? Well, we multiply by 1/10, or 0.1, so that would be your r. And then we solve this out, and we get our final answer, which would be 7/9. So, that's a very easy formula to work with, our infinite geometric series. And you'll be working with that more for your project and the little assessment that we have at the end. And then you'll really understand completely how to use this. Your homework is page 162, 1 through 40 odd. And the last thing I just wanted to say again, just to remind you guys that we talked about earlier, but just to remember, to find r, can't you always do the second term divided by the first term? So 2 divided by 1, won't that give you your r, which would be 2? And then, so if you ever get stuck and you can't figure out your r, kind of like that last question for infinite, can we do the second term divided by the first term, and we get this r instead? Perfect. Alright, I'll talk to you guys soon. Bye.